Imagine this. You wake up in the morning, stumble to your kitchen and turn on the tap. Crystal clear water flows out instantly, ready for your coffee, your shower, your dishwasher. Now imagine doing that same thing. But you're living in ancient Rome, over 2,000 years ago. Sounds impossible, right? Well, I'm about to blow your mind. Because the Romans didn't just have running water. They had a water system so sophisticated that it makes our modern infrastructure look like amateur hour. They built massive stone channels that carried millions of gallons of fresh mountain water across hundreds of miles, through valleys, over rivers, and straight into the heart of their cities. And they did it all without a single electric pump, computer, or even a decent calculator. Today, we're diving deep into the incredible world of Roman aqueducts, the ancient engineering marvels that would make Elon Musk weep with envy and Jeff Bezos start taking notes. Welcome back to Ancient Rome Revisited. I'm your host, Marcus Aurelius, and my God, I cannot thank the Roman engineers enough, not to mention the many millions of people who died on the job, for building what is one of the most important pieces of human innovation in all of history. If you haven't already yet subscribed to this channel, then please do so now. That way you'll never miss another episode of Ancient Rome Revisited. Okay, let's start at the beginning, shall we? The dawn of Roman water engineering. So why did the Romans become obsessed with moving water around in the first place? Well, imagine trying to run a city of over 1 million people. That's bigger than modern-day San Francisco, with nothing but a few wells and rainwater collection. By the 4th century BC, Rome was exploding in population faster than a TikTok trend goes viral, and their local water sources were about as reliable as Wi-Fi on an airplane at 30,000 feet. The Tiber River was there, sure, but it was becoming increasingly polluted with all the charming byproducts of urban life, sewage, industrial waste, and whatever else a growing metropolis tends to produce. If you catch my drift. Romans were literally dying of thirst while sitting next to a river because drinking from it was essentially playing Russian roulette with dysentery. The local wells were running dry faster than a desert mirage, and cisterns filled with rainwater could only do so much during Rome's notoriously dry summers. This wasn't just inconvenient. It was an existential crisis. A city can't grow beyond its water supply, and Rome had ambitions that stretched far beyond the 7 hills. They needed a solution that was bigger, bolder, and more audacious than anything the ancient world had ever seen. Enter Appius Claudius Caecus in 312 BC. Think of him as the Steve Jobs of ancient water management, except instead of revolutionizing smartphones, he revolutionized how an entire civilization thought about infrastructure. This guy looked at Rome's water crisis and said, "Hold my wine, I've got this." He wasn't just thinking about solving today's problem. He was envisioning a future where Rome could support populations that seemed impossible by ancient standards. Claudius conceived and built the very first Roman aqueduct, the Aqua Appia. Now calling it the first makes it sound primitive, like the Nokia brick phone of water systems. But this thing was an 11-mile engineering masterpiece that ran almost entirely underground, like some kind of ancient subway system for water. The Romans were so paranoid about enemies poisoning their water supply that they buried most of it, creating a hidden network that would make modern cybersecurity experts jealous. The Aqua Appia started at springs in the Alban Hills, about 10 miles southeast of Rome. Claudius didn't just randomly pick this spot. He chose this location because the Romans had figured out something that would make any modern city planner weep with envy. They understood that gravity is the ultimate free energy source. No monthly electric bills, no maintenance crews, no fossil fuels, just pure physics doing all the heavy lifting for eternity. The water flowed downhill from the springs, through carefully engineered channels carved from solid rock, and emerged in Rome like magic. But here's the kicker. The entire system was designed with a gradient so precise that the water maintained perfect flow velocity. Too steep, and the water would erode the channels. Too shallow, and sediment would build up and clog the system. The Romans nailed this calculation using nothing but geometry and obsessive attention to detail. The Roman engineering toolkit. Now, here's where things get absolutely mind-blowing. The Romans built these aqueducts using tools that would look primitive in your average garage sale today. Yet they achieved precision that would impress the engineers building the James Webb Space Telescope. Their toolkit was basically the ancient equivalent of MacGyver's, simple, but used with incredible ingenuity and mathematical precision that would make MIT graduates nervous. First up, the chorobates. Picture a 20-foot-long wooden beam with legs, basically a giant ancient level that looks like it belongs in a prehistoric carpentry shop. But don't let its simple appearance fool you. This device was the GPS of the ancient world. The Romans would use this, combined with plumb lines and water-filled grooves, to ensure their aqueducts maintained the perfect gradient across hundreds of miles. And when I say perfect, I mean we're talking about a slope of just 1 to 3 feet per mile. That's like trying to thread a needle while riding a roller coaster during an earthquake. To put this in perspective, imagine trying to build a ramp from New York to Philadelphia that drops exactly 240 feet over 95 miles, and if you're off by even a few inches, the entire system fails catastrophically. That's the level of precision Roman surveyors achieved with wooden sticks and string. They also used something called a dioptra, which was essentially the ancient world's version of a surveyor's transit crossed with a scientific calculator. This bronze contraption, invented by the Greeks but perfected by Roman engineers, helped them sight across long distances and calculate angles with remarkable accuracy. Imagine trying to aim a laser pointer across multiple mountains and valleys, except your laser pointer is a complex system of rotating bronze discs, water levels, and precisely calibrated viewing ports. The dioptra could measure both horizontal and vertical angles, allowing Roman surveyors to create detailed topographical maps and plan aqueduct routes that would thread through seemingly impossible terrain. Some of these surveys were so accurate that when modern engineers retrace Roman aqueduct routes using satellite technology, they find the ancient calculations were correct to within inches. For the actual construction, Roman engineers employed a combination of techniques that would make modern contractors cry tears of frustration and admiration. They used a concrete-like mixture called opus cementitium, essentially volcanic ash, lime, water, and aggregate that could set underwater and lasted for millennia. Meanwhile, our modern concrete starts developing cracks after a few decades of freeze-thaw cycles, and we consider a 50-year lifespan for infrastructure to be pretty good. Roman concrete wasn't just durable, it actually got stronger over time as seawater reacted with the volcanic ash to create new mineral compounds. It's like they accidentally invented self-healing concrete 2,000 years before we even knew that was a thing we wanted. The Romans also mastered the art of the arch, which distributed weight so efficiently that many of their aqueduct bridges are still standing today, while modern bridges require constant maintenance and eventual replacement. They understood that an arch could carry loads that would crush a simple beam faster than you can say catastrophic structural failure. This wasn't just building, This was architectural chess played at a grandmaster level, where every stone was precisely calculated to work in harmony with every other stone, conquering impossible terrain. But here's where the Romans really showed off their engineering swagger, dealing with terrain that would make modern engineers reach for the antacids and start updating their LinkedIn profiles. When they encountered a valley that seemed impossible to cross, they didn't just say, "Well, I guess we'll stop here and call it a day." They built massive arched bridges that soared hundreds of feet in the air, carrying precious water across gaps that seemed to defy the laws of physics and common sense. Take the Pont du Gard in southern France. This absolute unit of ancient engineering is 160 feet high and nearly 900 feet long, built from limestone blocks weighing up to 6 tons each. The Romans assembled this architectural Lego set without cranes, without modern machinery, without even steel cables, using only human labor, rope pulleys, wooden scaffolding, and what can only be described as absolutely legendary teamwork. It's like building the Golden Gate Bridge using nothing but hand tools, Roman determination, and a really, really good attitude. The precision required was insane. Each stone had to be cut to exact specifications and fitted perfectly with its neighbors. The slightest miscalculation would result in catastrophic collapse, probably taking half the workforce with it. Yet the Romans pulled it off so well that this bridge has survived floods, earthquakes, and 2,000 years of weather that would have destroyed lesser structures. When they hit a mountain that blocked their path, they didn't go around it like reasonable people might. They went straight through it because apparently impossible wasn't in the Roman vocabulary. Roman engineers carved tunnels through solid rock using a technique that sounds like something out of a cartoon, but actually worked. Fire and vinegar. Here's how this worked. They'd heat the rock face with massive fires, raising the temperature until the stone was practically glowing. Then they'd douse it with vinegar. Yes, regular vinegar. The same stuff you put on your fish and chips. The acid would cause thermal shock and crack the stone, creating fractures that could be hammered away with hand tools. It was slow, dangerous, back-breaking work that would have made OSHA inspectors faint on the spot, but it got the job done. The longest tunnel, serving the Aqua Claudia, stretched for over 4 miles through solid rock. That's like boring through Mount Rushmore with a chisel, some vinegar, and the patience of a saint. Teams of workers would tunnel from both ends simultaneously, meeting in the middle with accuracy that would impress modern tunnel-boring machine operators. Sometimes the terrain was so challenging that the Romans had to get creative with physics itself. They developed inverted siphons, essentially giant stone pipes that carried water down one side of a valley and up the other side, using water pressure to push the flow uphill against gravity. These systems worked on the same principle as those loop-the-loop Hot Wheels tracks you played with as a kid. Except instead of toy cars, they were moving millions of gallons of water daily through carefully engineered pressure systems. The engineering required for these siphons was mind-boggling. The Romans had to calculate water pressure, pipe strength, and flow dynamics without modern mathematics or computer modeling. One miscalculation, and the entire system would either burst from pressure or fail to carry water uphill. Yet these siphon systems worked flawlessly for centuries, some still functioning today. The aqueduct network explosion. After the stunning success of the Aqua Appia, Rome went absolutely aqueduct crazy. It was like the ancient equivalent of a tech startup getting its first round of venture capital funding and deciding to disrupt the entire industry. Roman engineers became the rock stars of the ancient world, and every emperor wanted to leave their mark by building the biggest, longest, most impressive aqueduct possible. Over the next 500 years, they built 10 more major aqueducts serving Rome alone, creating a network that could deliver over 300 million gallons of water daily to the city. That's enough water to fill about 450 Olympic-sized swimming pools every single day, or supply a modern city of 3 million people. Remember, this was 2,000 years ago, when most of the world was still figuring out basic agriculture. Each new aqueduct was more ambitious than the last, like a never-ending game of hold my beer and watch this. The Aqua Marcia, completed in 144 BC, stretched 57 miles from its source to Rome, and was considered the Rolls-Royce of Roman water systems. Its water was so pure and delicious that wealthy Romans would specifically request Marcia water for their dinner parties, like some kind of ancient luxury brand. Imagine being so bougie that you have a preferred brand of tap water and can actually tell the difference. The water quality was so good that Roman physicians recommended Marcia water for patients with stomach ailments, and it became fashionable among the upper classes to distinguish between different aqueduct waters, like we might distinguish between different brands of bottled water today. Some Romans claimed they could taste the difference between water from different sources, the ancient equivalent of being a water sommelier. The Aqua Tepula, built in 125 BC, introduced the concept of lukewarm water. Tepula means lukewarm in Latin, bringing naturally heated water from hot springs directly to Roman baths. This was like having a built-in water heater system that required no fuel and no maintenance, just naturally heated water flowing constantly into the city's bathing facilities. But the real showstoppers were the Aqua Claudia and Aqua Annio Novus, both completed under Emperor Claudius in 52 AD. These were the final boss level of Roman engineering, the engineering equivalent of landing on the moon while juggling flaming torches. The Aqua Claudia stretched 45 miles and featured some of the most spectacular arched sections ever built, including stretches where the water channel ran 100 feet above ground level, supported by arches so massive they looked like ancient skyscrapers. The Aqua Annio Novus was even more impressive at 54 miles long and could carry an astounding 79 million gallons daily. To put that in perspective, that's enough water to supply modern Las Vegas for several days. The construction of these aqueducts required moving millions of tons of stone, employing thousands of workers, and coordinating logistics that would challenge modern project managers with all their digital tools and communication systems. But Rome wasn't the only city getting the aqueduct treatment. As the Roman Empire expanded across Europe, North Africa, and the Middle East, so did their water engineering prowess. They built aqueducts in Spain, France, Germany, Britain, Turkey, and across the Mediterranean, each one adapted to local terrain and conditions, but maintaining the same high standards of Roman engineering excellence. Some of these provincial aqueducts were even more impressive than the one serving Rome itself. The aqueduct serving Carthage in North Africa was over 80 miles long and had to cross desert terrain where water was more precious than gold. The system serving Lyon in France featured a series of siphons and bridges that would make modern hydraulic engineers jealous. In Spain, the aqueduct serving Segovia is still functioning today, delivering water to a modern city using 2,000-year-old Roman engineering. The aqueduct system in Constantinople, modern Istanbul, was perhaps the most complex of all, featuring multiple aqueducts feeding into a sophisticated distribution network that included the famous underground cisterns that still amaze tourists today. These cisterns could store millions of gallons of water, providing a strategic reserve that could sustain the city during sieges or droughts. Life-changing water revolution. Now, let's talk about how these aqueducts completely transformed Roman society, because we're talking about a social revolution that makes the internet revolution look like a minor software update. This wasn't just about engineering. This was about fundamentally changing how human beings lived, worked, and thought about urban life. Before aqueducts, getting water was like waiting in line at the DMV, time-consuming, frustrating, and something you had to plan your entire day around. Women and slaves would spend hours daily hauling water from wells or the increasingly polluted Tiber River, carrying heavy clay amphorae on their heads like some kind of ancient CrossFit workout that nobody signed up for. A single amphora could weigh 50 pounds when full, and a typical household needed multiple trips daily just to meet basic needs. This water-fetching routine wasn't just inconvenient. It was a full-time job that prevented people from pursuing other activities. Women couldn't engage in commerce or crafts because they spent half their day hauling water. Children couldn't attend school because they were needed to help with water collection. The economic impact was enormous. A significant portion of urban labor was dedicated to simply obtaining the most basic necessity of life. After aqueducts, Romans had running water that would make modern city dwellers jealous. Not just any water, clean, fresh mountain water flowing right into their homes, their shops, their public baths, available 24/7 without interruption. The wealthy had private connections to their houses, essentially becoming the first people in human history to have indoor plumbing that didn't involve a chamber pot and fervent prayers to the gods. But even ordinary citizens benefited enormously. Public fountains popped up on every street corner like ancient Starbucks locations, except instead of overpriced coffee, they dispensed free, clean water to anyone who wanted it. These weren't just functional. They were architectural masterpieces, decorated with elaborate sculptures, marble carvings, and inscriptions celebrating the emperor or the aqueduct that supplied them. These fountains became the social media of the ancient world, places where Romans would gather to chat, gossip, conduct business, and catch up on the latest news. It was the original water cooler conversation, except the water cooler was a marble masterpiece that took master craftsmen months to carve and install. Romans would arrange to meet at specific fountains, children would play around them, and merchants would set up nearby to catch the foot traffic. But the real game changer was the public baths, the ancient equivalent of luxury spas that put modern facilities to shame. Roman baths weren't just places to get clean, they were like ancient country clubs, complete with hot pools, cold pools, steam rooms, saunas, massage rooms, libraries, restaurants, art galleries, and even lecture halls where philosophers would give talks. The baths of Caracalla could accommodate 1,600 bathers at once and featured amenities that wouldn't look out of place in a modern 5-star resort. There were heated floors, adjustable water temperatures, a full range of bathing experiences from frigid plunges to steamy hot soaks, and professional massage therapists. The complex included gardens, shops, and recreational facilities where Romans could spend entire days socializing and relaxing. All of this was possible because aqueducts provided the massive amounts of water needed to fill these giant facilities. The baths required millions of gallons daily, water for the pools, water for the steam systems, water for cleaning, water for the elaborate fountains and decorative features. Without aqueducts, none of this would have been economically feasible. The aqueducts also revolutionized urban sanitation in ways that wouldn't be matched again until the 19th century. Romans developed the first flush toilets, comprehensive sewage systems, and waste management infrastructure that actually worked effectively. The famous Cloaca Maxima, Rome's main sewer system was fed by aqueduct water and could flush away the waste of over 1 million people daily. While medieval Europeans, centuries later, were still throwing their waste out windows and hoping for the best, and dealing with regular cholera and plague outbreaks as a result, Romans had developed a sophisticated public health system that would make modern sanitation engineers weep with admiration. Disease rates in Roman cities were dramatically lower than in medieval European cities, largely due to their superior water and waste management systems. Urban planning was transformed too. With reliable water supplies, Roman cities could grow larger and more densely populated than ever before in human history. They could support water-intensive industries that would have been impossible without aqueducts, textile production, which requires enormous amounts of water for dyeing and cleaning, leatherworking, which needs water for tanning processes, metal processing, for cooling and cleaning, and food production, for cleaning, cooking, and preserving. The aqueducts didn't just bring water, they brought economic prosperity, urban sophistication, and quality of life improvements that wouldn't be matched again for over 1,000 years. Roman cities became magnets for trade, culture, and innovation, largely because they could support larger populations in greater comfort than anywhere else in the ancient world. The engineering legacy that echoes through time. As I wrap this up, I want you to think about something that will absolutely blow your mind. Many Roman aqueducts are still functioning today. Not kind of working, not partially operational, not museum pieces, fully functional, actively delivering water to modern cities after 2,000 years of continuous service. That's like finding a smartphone from the year 24 AD that still gets 5G coverage and runs the latest apps. The aqueduct serving Rome's famous Trevi fountain? That's the restored Aqua Virgo, originally built by Marcus Agrippa in 19 BC. Every coin you toss into that fountain, every wish you make, is landing in water delivered by engineering that's older than Christianity, older than the Great Wall of China, older than most of the world's major religions. The next time you're in Rome throwing coins and making wishes, remember that you're participating in a ritual made possible by toga. Wearing engineers who calculated gradients with wooden sticks, modern engineers don't just study Roman aqueducts as historical curiosities. They study them as examples of sustainable, durable infrastructure that we're still trying to match. While we struggle with water systems that need constant maintenance, regular replacement, and consume enormous amounts of energy, the Romans built theirs to last millennia and operate purely on gravity. NASA engineers have studied Roman concrete to understand how to build structures that could last for centuries on Mars. Urban planners examine Roman water distribution systems to design more efficient modern networks. Environmental engineers are fascinated by Roman techniques for maintaining water quality over long distances without chemical treatment. The Romans understood something we're still trying to figure out in our modern world, that the best technology isn't always the most complex. Sometimes it's the most elegant, the most sustainable, the most perfectly adapted to work in harmony with natural forces rather than fighting against them. Contemporary engineers armed with supercomputers, satellite imagery, laser measurement tools, and advanced materials, science still struggle to build infrastructure that matches the longevity and reliability of Roman aqueducts. There's something humbling about realizing that some of humanity's greatest engineering achievements were accomplished by people who thought the earth was the center of the universe and hadn't invented the wheelbarrow yet. The next time you turn on your tap and clean, safe water flows out instantly, remember that you're participating in a daily miracle that was perfected by toga-wearing engineers who moved mountains with fire and vinegar, who calculated precise gradients across hundreds of miles using wooden levels, who built bridges that have outlasted empires and continue to carry water to this day. The Romans didn't just build aqueducts, they built the foundation of urban civilization itself, one precisely calculated stone at a time. They proved that with enough determination, mathematical precision, and engineering brilliance, humans could reshape the landscape itself to serve their needs, bringing life-giving water across impossible distances to create cities that would be the envy of the ancient world. And that, my friends, is why Roman aqueducts don't just belong in history books, they belong in the Engineering Hall of Fame, right next to the internet, the printing press, the steam engine, and whatever incredible innovations we'll come up with next. Because some ideas are so fundamentally brilliant, so perfectly executed, that they transcend time itself and keep flowing, just like the water in those ancient channels for thousands of years to come, inspiring each new generation of engineers to reach for the impossible and make it reality. If you enjoyed this video, then please subscribe and you'll never miss another episode of Ancient Rome Revisited. Thank you for joining me today as I walked you through the history behind some of the most important and impressive pieces of engineering in all of history. I look forward to seeing you in the next video.